Hey guys, I hope y'all are having a great day. Today, I'm going to do a tutorial video on Unit 2, Lesson 6. This topic, the main topic that is kind of challenging within this section that's also going to come up in Unit 3 is electron configuration. So I'm going to ask you to pay attention because this is not only going to be on your Unit 2 quiz and your Unit 2 test, it's going to be on your Unit 3 quizzes and your Unit 3 tests. And tests are worth like 60% of your grade. So not to stress you out, but also just take your time, get some paper if you want to. If you have the ability to like have a periodic table printed in front of you, that's great. Or if you have an online one you want to look at, that's great. But make sure you're paying attention and taking some notes. That way this makes sense to you. So the first thing we need to know about to understand this is what an energy level is. An energy level, if you think about like the rings on an atom, like if I were to draw a little atom right here and this is the nucleus, it will you might imagine that it has these rings around it, right? With these electrons orbiting it, kind of like this. And you may have seen this type of picture before where each ring is actually an energy level, right? So an energy level is kind of like in this reference, we use the word N for it. So you can think N for energy. And it corresponds to the rows on the periodic table. So I'll show you in a second that it corresponds to the rows on the periodic table. And the analogy I have for this is like the neighborhood street that you might live on or that an electron might live on. So the energy level is like the neighborhood street where an electron is located. Electrons move super, super quickly. So we know, okay, if I'm on energy level 2, my electron is somewhere in this neighborhood area, somewhere on this street. So it's kind of like a broad category for where the electron is located. And then within every energy level, every row on the periodic table, there are sublevels. And I like to compare sublevels to like a house on the neighborhood street, on the street. So if I'm trying to really figure out, okay, where is my electron? The energy level just tells me the general street it's on. The sublevel tells me a little bit more information. It tells me what section or what house the electron is living in or where it is, kind of. It's all about identifying where the electrons are. So not only do electrons have these energy level rings, but we actually have different sections that they reside in. And then the orbital, we'll talk more about this later, but it's almost like the room in the house. So it's the most specific out of all of them. And the rule for this is that 2 electrons can fit per bedroom. Now, I want you to just hold on to this information because we're not gonna use this today or in this video. We're gonna use it to talk about orbital diagrams later, but really we're only gonna focus on these 2 things right here. So when I say a sublevel, there are 4 different sublevels: S, P, D, and F. These are the sublevels that there can be, okay? But the first energy level actually only has the S houses on its neighborhood street. The second energy level actually has the S and the P house. So it's like a 1-bedroom versus like a 3-bedroom. So as you go down energy levels, your options increase. So the first one only has the S block, the second one has S and P, third one has S, P, and D, and the fourth one has S, P, D, and F. So those are the sublevels or the sections where the electrons are probably located. And this is what the houses kind of look like. Remember, sublevels are kind of like houses. So when I say, oh, my electron is on the S sublevel, this should say sublevel next to it. I'm sorry, not orbital. So replace all these with the word sublevel. If my electron is on the S sublevel, it means that it is generally like within a certain sphere. If my electron is on the p orbital, it actually is within this area of space right here. So it's pretty bizarre and pretty mathematical. Like these are like mathematical drawings of where the electron is probably located. And it's like in these 3D spaces on the atom, which is kind of weird. So I just wanted to show you, this is what they actually, the space that they take up, kind of what they look like, or where the electrons are. The electron could be anywhere in here bouncing around, right? So looking again, like we said earlier, each energy level, you know, there are different sublevels, right? So we're going to actually look at it on the periodic table. So looking here, this is the first energy level right here. This is the second one. This is the third, fourth, fifth, sixth, seventh. Okay, but let's just break it down. So looking at the first energy level on this row, you see only pink. There's only the S sublevel, right? This over here is actually also a part of the S sublevel. Looking at the second energy level, we have S and we have P, right? There's two sublevels there. For the third energy level, we have S, we have P, and if you notice something weird, we have D down here. The D block is kind of shifted. I mean, if you think about it, it should be shifted up, right? It's kind of weird, but for the D block, it's shifted up or shifted down one. So really, this 3D comes after the 4S. So it's kind of like shifted down one for that section. So we'll talk about that. So just keep a pin in that for the D block. When we're on the fourth energy level, we have the 4S, the 4P, the 4D, and then down here we have 4F when you're on the fourth energy level. So I just wanted you to get aware of like what this looks like. And I know it might be a little bit overwhelming, but practice is what really kind of helps solidify what you need to know here. So here are some questions that you will have, and we'll also do actual questions on the lesson. So let's try to write the electron configuration for hydrogen, which is H, okay? First of all, let's find H right here. Here's H. H is atomic number 1, right? So that means that H has 1 proton, which means that H basically has 1 electron, assuming that it's neutral. Because if it's neutral, positives and negatives cancel out. So we'll have 1 proton, 1 electron. So H has 1 electron. And if I want to write its configuration, I need to list the energy level, the sublevel, and then the number of electrons that are in that sublevel. So looking at H right here, what energy level does it look like I am on? Hold on, right here. So looking at H, what energy level is this on? Well, the question I'm asking is what row is it on? You can see right here, this is the energy level. It's on energy level 1, right? And then the next thing that we write is the sublevel. What sublevel is H on? You can see right here, it's kind of telling you it's on the S sublevel. So everything within the blue right here, the light blue, and it's also helium over here, they're on the S sublevel. So H is on the S sublevel. And then now I ask, how many electrons or how many blocks in is it? Well, hydrogen is only 1 block in. It has 1 electron. So we're only going to list 1. The electron configuration for hydrogen is going to be 1s1. The example here shows 1s2. 1s2 would be the electron configuration for helium because it's also on row 1, section S, but it is 2 blocks in, 1, 2. So 1s2 would be for helium. Let's try another one now. Let's see right here. Write the electron configuration for carbon. Let's find carbon. Carbon is right here. So here's how this works. When you have something further in the periodic table, you are always going to start at hydrogen. You're going to start right here. And we're going to read from left to right. And we're going to list the row or the energy level, the sublevel, and then how many blocks are in that sublevel. So we're doing it for carbon. So starting with hydrogen, what row are we on? Well, at the very beginning, we're on row 1. What sublevel or section do we hit first? Okay, the first thing we hit is the S sublevel. How many blocks are in that sublevel? 2 blocks are in that sublevel, right? Hydrogen and helium. So now we've finished the first row, and we're going to go down to the second row. We're on energy level 2, and again, we're hitting section S, and there are, again, 2 blocks there, Li and Be. So now we've done this section. We're trying to get to carbon. So we're still on row 2, section P, and we are now 2 blocks in until we hit carbon. So we're going to stop right there. 1s2, 2s2, 2p2. So what the heck did we just do? What we did was we listed out where all of carbon's electrons are because carbon's number is 6. Carbon has 6 electrons, right? Well, look what this adds up to. 2, 4, 6. What we're saying is that 2 of carbon's electrons are here, 2 of them are here, and 2 of them are here. It just happened to be this pretty this time. It won't always be the same number on top, but you count the row, the section, how many, row, section, how many, left to right and down until you hit the element you're trying to find. So let's try another one. Let's do it for manganese. Let's find manganese. Manganese is confused with this one right here, but manganese is actually right here. So again, we need to start at hydrogen. We're going to list the row, the section, and how many. So starting at hydrogen, we're on row 1, section S, and there are 2 blocks here, right? So I've done that section. Now, after I've done that, I'll be on row 2, section S, and there are 2 blocks that are in section S. S can only ever hold 2 blocks. Now we're going to jump over because we're going from left to right. So I'm still on row 2, and now what section am I on? I'm on section P. And how many blocks are here? 1, 2, 3, 4, 5, 6. So now I'm done with row 2. And now I'm going to go to row 3. Section S is the first one I hit. And there's 2 blocks there. I'm just going to keep on going across. I'm not going to skip down or anything. I'm just going to keep going across. So row 3, section P. 1, 2, 3, 4, 5, 6, 3P6. Now I'm done with row 3, and now I'm on row 4. Row 4, section S, 2 blocks like that. And then the last part here is now, it looks like I'm on row 4 or energy level 4, but remember the D block shifts down 1. So when you look right here, that actually says 3D. So I'm going to write down 3D, and I'm going to count. But I'm going to stop when I hit manganese because I'm trying to get to manganese. 1, 2, 3, 4, 5. So this is the electron configuration for manganese. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. It's a lot, right? But again, we're just reading from left to right and listing it out. I have good news for you though. There is a way to abbreviate and do a shorthand notation. Like who wants to write all of that out? Not me. So I'm going to show you how to do the shorthand notation, which your lesson will ask you to do as well. So I'm just going to kind of restart here a little bit. Okay. So to do the shorthand notation for manganese, you've got to go to the previous noble gas. So do you remember what a noble gas is? Noble gas is all of the elements in group 18 right here. So what I like to do is I like to go to the next one. The next noble gas would be krypton, right? These are the noble gases. The next one from manganese, when you think about the next one, it would be krypton. To get to the previous one, I like to go over and then up 1. Argon would be the previous noble gas because you kind of just go over and then up 1. So you can go to the previous noble gas, and then the good news is you can start there. Okay, so rather than starting all the way at hydrogen, we can start at argon. That means that we have already basically taken care of everything before argon, going from left to right. So we have already taken care of all of this. We don't have to list all of it out. And we just have to start where argon left off. So we're starting at 4s2 right here, and then 3d5. Because remember, it was 2 for the S section, and then 5 for the D section right there. So this would be how you shorthand, and we're going to do a little bit more with that. Okay, let's do tungsten, but let's do the shorthand for tungsten to save us some time. So tungsten is, let's see if I can find it. It's this one right here. Tungsten's abbreviation is W, which doesn't really make sense, but it's W. So to do the shorthand, we need to find the previous noble gas. So again, I like to go over to the next noble gas, which is Rn, and then when you go up 1. So our previous noble gas is going to be Xe. And if it helps you, hold on. If it helps you, we can cross out everything up before Xe, the previous noble gas. Like, let's just draw a line through it. That means that we've already taken care of everything before Xe, right, from left to right. So we have to start right here on row 6, and we're trying to get to W. So this one's a little bit trickier, so pay attention. We're on row 6. Section S is the first section we hit, and how many blocks are in that section? 2. After section 6 right here, you can see the F block kind of comes out of that. If you see this line, this row is on the 6th row and it's coming out of it. So we actually need to, if we're like doing this in order, we're going to list it first. We're kind of going to like skip the LA for a second and list the F section first because it comes out of row 6. So this only applies to things that are on row 6 or row 7 after the F block. So row 6, and now we're going to do 4F, and then we're going to count how many are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 in the F block. And now we're going like back up to here, which is 5D. And we're going to just count how many are there. 1, 2, 3, 4. Okay. So 6S2, which is this part right here. 4F14, which is this part right here that kind of came out of it. And then 5D4, 1, 2, 3, 4. When you're dealing with the F block, you kind of like jump past these first two and you do the F block, and then you kind of go back and start on the D block. So the F block is a little bit confusing. You'll only have, I think, 1 or 2 like that. So now let's do some practice problems from your lesson. This is from your lesson. Select the correct electron configuration for calcium. So select the correct electron configuration for calcium. So let's go find calcium. Let's have my rows listed again here. Calcium is right here. So we need to start, if we're doing it the long way, we start at hydrogen, right? You start at the very beginning and you list the row, the section, and how many blocks are in that section. There are 2 blocks in that section, right? Now we finish that row, we're on row 2. Again, this is section S. The light blue this is all S, right? And there are how many blocks in this section? 2 of them. Now we're going to hop on over. We're going from left to right. So we're still on row 2, but now we're on section P. And we need to count how many blocks are here. 1, 2, 3, 4, 5, 6. 2P6. And now 3S2 is next right here, right? And then now 3P6 because 1, 2, 3, 4, 5, 6. And now we're trying to get to calcium. So row 4, section S, and then 2 blocks in, 1, 2, and we have hit calcium. So this is the electron configuration for calcium. I'll write it over here as well. This is the electron configuration for calcium. To do the abbreviated, like problem 23 asked you to do, the shorthand version means that we have to go to the previous noble gas for calcium. So looking at calcium right here, what would the previous noble gas be? It looks like it would be, so I like to go to the next one over. The next one's krypton, so the previous one would be argon, the previous one. And that means that everything has already been taken care of up to that point. So we only have to start where argon left off, which is row 4, section S, 2 blocks in. Basically, all of this got taken care of. It was already in like before argon, and this is what's left over. Okay, so let's try again for CD. So let's find CD. This is also one of the problems in your lesson, number 17. So CD is right here. So we need to list the, starting at hydrogen, the very beginning, the row, the section, and how many. So here are my rows again. So we're starting at hydrogen, we're on row 1, section S, 2 blocks in. Then we're on row 2, section S, 2 blocks in. There are only ever 2 in the S block. And then now we're on the P block. The P block always has 6, unless it's like, you know, only partial because we're trying to get to that one. 2P6. And then now we're on the 3rd row, section S, 2 blocks in. Now we're still on the 3rd row, but now we're on section P, and again, 6 blocks in. Now row 4, section S, 2 blocks in. And then see, this is row 3 because the D block shifts down 1, and there are 10 blocks here if you count the pinkish red color there. Now we're back up to row 4. It goes back up for P, and there are 6 blocks here. We're trying to get to cadmium. We're close. Now row 5, section S, 2 blocks in. Okay. We don't have to deal with the F block, thankfully, because that only is for row 6 and 7. So now we're on 4D because the D block shifts down 1, and we're going to count until we get to cadmium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is the 10th one there. So this is the electron configuration for cadmium. Let's try it shorthand to save us some time because that was a lot of work. So pause it here if you need to choose this. I'm going to erase this so that I can kind of clean up a little bit. I'm going to go back just a little bit here. We just need to go to the previous noble gas, right? Hold on. The previous noble gas. So for cadmium, the previous noble gas, you go over and then up 1. It would be krypton, which means that we just have to start there. Everything else is taken care of. So after krypton is row 5, section S, 2 blocks, row 4, section D, and then we counted already to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the abbreviated version for cadmium, which is the answer to number 24 on your problems. And that's all that we're going to deal with today. Come to my classroom now to ask any follow-up questions. Seriously, this stuff is difficult and it's going to follow you in Unit 3. So come to my classroom now and be like, okay, I kind of get it, but I want to work through a couple more, or I kind of get it, but I need help with this part. So just come to my classroom if you need help at this point. You're doing a great job. Super proud. I'll talk to you soon.